In this video, we will perform the electrolysis of table salt and we will measure the amount of released hydrogen using the Arduino UNO. Hydrogen is a chemical element with a symbol H and atomic number 1. It is the simplest chemical element and the most abundant chemical substance in the universe. It makes up roughly 3/4 of the mass of the universe. It can be found in water and in all organic matter. Hydrogen gas is clear, colorless, tasteless, odorless, and flammable. It is the lightest of all gases. It has a number of important applications. For example, it is used in the production of various chemical compounds such as ammonia, nitric acid, methyl alcohol, and various nitrogen fertilizers, in the production of certain metals, and in the hardening of oils. Oxyhydrogen flame is used for welding and cutting metals. Liquid hydrogen can be used as a source of energy for various devices. For example, it is used as rocket fuel. To measure the amount of hydrogen in the air using the Arduino, we will need the following components: Arduino UNO, hydrogen sensor, LCD display, breadboard, jumper wires, and a USB cable. The detection of hydrogen is based on change of resistance of the sensing material when the gas comes in contact with the material. Using a simple voltage divider network, concentrations of gas can be detected. When tin dioxide is heated in air at high temperature, oxygen is absorbed on the surface. In clean air, donor electrons in tin dioxide are attracted toward oxygen, which is absorbed on the surface of the sensing material. This prevents electric current flow. In the presence of reducing gases, the surface density of absorbed oxygen decreases as it reacts with the reducing gases. Electrons are then released into the tin dioxide, allowing current to flow freely through the sensor. Our circuit schematic looks like this. First, wire the sensor to the Arduino. Connect the ground pin to the GND pin of the Arduino and connect the VCC pin to the 5V pin of the Arduino. Connect the AO pin to the analog pin A0 of the Arduino. Then, wire the LCD display to the Arduino. Connect the ground pin to the GND pin of the Arduino and connect the VCC pin to the 5V pin of the Arduino. Connect the SDA pin to the analog pin A4 of the Arduino and connect the SCL pin to the analog pin A5 of the Arduino. Electrolysis is a cyclochemical process caused by the passage of an electric current through a solution during which chemical changes occur at the electrodes. The conductive solution contains a mixture of positive and negative ions, which are formed by the dissociation of molecules. The passage of an electric current causes the movement of positive ions, cations, to the negative electrode cathode, and negative ions, anions, to the positive electrode anode. A chemical reaction can then take place at the electrodes, between the ions and the electrode, between the ions themselves, and between the ions and the solution. The electrical voltage between the electrodes directs the movement of the sodium cations to the negative electrode, from which it receives an electron and changes into an electrically neutral particle, sodium atom. Chlorine anions move towards the positive electrode, which receives an electron, and each two chlorine atoms combine into an electrically neutral chlorine molecule. Sodium hydroxide and hydrogen are formed at the negative electrode. Chlorine gas is formed at the positive electrode. For this experiment, we will need the following supplies: a bowl or a jar, two pencils sharpened at both ends, sodium chloride, table salt, a lemon, two conductors, and 9V battery. First, we prepare the electrolyte, aqueous sodium chloride solution. Pour water into our glass, mix 2 teaspoons of table salt and few drops of lemon juice. We connect the pencil or carbon electrodes to the opposite poles of the battery using wires. Insert the electrodes into the solution so that they do not touch each other. This is our program. First, we need to include the required library and define all the necessary variables. In the setup section, we set the speed in bits per minute, at which information will be transferred from the Arduino to the computer, and then we calibrate our sensor. The sensor must be in clean air during the calibration. Next, we initialize the interface to the LCD screen and specify its dimensions. In the loop section, we will display the values measured by our sensor on the LCD display and send them to the serial port. The last part of the program consists of calculation of the necessary variables.